Let's do question 7a. The market value of John's house is increased at a constant annual exponential rate of 4.5% since he bought it on 1 January 2008, and then on 1 January 2021 his house was worth 3,500,000. Determine what the value of his house was on 1 January 2008 when he bought it. Okay, we want to try and understand the information that we're given here. So, constant annual exponential rate. So it means here we're talking about exponential growth. And then exponential growth, it means we're talking about what? Compounded growth. Remember, when you talk about compound interest and simple interest, when the money or the loan that you take or the investment that you make grows exponentially, it means that the interest is compounded. Okay, but if it is simple interest, the growth is linear. Let me just try to show you using the graph. So now we have this graph here, and then let's say 1,200,000 was invested here. If it grows exponentially, it will grow like this. You see, it grows exponentially. That's compound interest. But simple interest grows in what? In a linear. It exhibits a linear growth. So it means here we're talking about compound growth. So we're going to use the compound interest formula. We're going to use compound interest formula. Right, let's go to the formula. So this is the formula that we have to use here. Right, let's write the variables that we have and see which one we are supposed to calculate. So A here, what is it? A, this is the future value, the value that P is going to accumulate to. So it means the value we're talking about here is 3,500,000. So that's A there. It's not a must to write this, but let me advise you to do this. Okay, make sure that you check everything that you write. Check, because don't make a mistake. Okay, A here is 3,500,000. And then P, the principal amount, that's what we're looking for. What was the price of the house in 2008? Now in 2021, it is 3,500,000. What was the price when it was bought? Right, and then I, we have it. It says the constant annual exponential rate. So this is like 4.5% compounded what? Annually. It's just the same thing as that. So this is 4.5 over 100. Can use a decimal here, 0.045, or you can use the percentage, 4.5%. It's just the same thing. And then N is 13, which is the number of years there. How do we get that the number of years is 13? We are subtracting here the years, you see, from 1 January 2008 to 1 January 2021. So this is 13 years. Please take note that N is not like number of years. N is the number of times the interest is added. But here, because the rate is annually, so it means that the interest is going to be added how many times? Is going to be added 13 times. So the number of times the interest is added is equivalent to the number of years. But take note, N is not the number of years. Because let's say if it was compounded monthly, it was not going to be 13, it was going to be 13 times 12. If it was compounded quarterly, it was going to be 13 times 4. You see that? So here, interest is added once a year. So the now N becomes equivalent to the number of years because of that. right now, and then we can substitute into our formula. So what we have, A is 3,500,000 is equal to P, that's what we're looking for, 1 plus I, which is 4.5%, and then the exponent there is 13. You see that? And then we have substituted into the formula. And then what we do, we have to now solve for P. And then how do we do that? So we can divide both sides by this whole bracket here. So it becomes 3,500,000 divided by the whole bracket, 1 plus 4.5% to the power 13 is equal to P. You see that? And then just put this in the calculator, this whole thing in the calculator. What do you get? This. If you put this in the calculator, you'll get your P. So it means it is 1,974,950 rand and 74 cents. Right, that is our P there. Okay, done. So we have done the first part of our question. We're going to do 7B in the next video.